All right, boys and girls, welcome back to day 11. Today we're starting to do some geometry. Now I've divided this section into three parts, which is going to be lines and segments and rays at the first part. And then we're going to talk about angles. And lastly, we're going to talk about parallel and perpendicular lines and the line that's cutting them, which is a very common question type in SAT that always comes up. So make sure you stick around and make sure you pause the video to try the questions for yourself. Now for the first part, I'm going to talk about line segments and rays, but I don't want to do any theory here. We're only 10 days away from the exam, so I'm assuming you already know what they are. But we are going to do some practice. In the figure above, Q is the midpoint of PR. That's another a definition that we can quickly review. Midpoint, obviously, I'm sure you know, there's a middle of 2 points, which means the distance from the beginning to midpoint is equal to from midpoint to the end. So PQ distance is supposed to be equal to QR based on the definition of midpoint. If PQ is equal to x plus 3 and QR is equal to 2x minus 1, what is the line segment of PR? So we're interested in the whole thing. Okay, so like we said, because of the midpoint, we know that PQ is supposed to be equal to QR, right? And then which means x plus 3 supposed to be equal to 2x minus 1. Now we can move things around a little bit. So bring the 2x to the left. That's going to be negative x. Move the numbers to one side, negative 1 minus 3, which is going to be negative 4. Multiply both sides by negative 1. X is going to be 4. So what did we just found? We found x, which means now we can find what PQ is, which is x plus 3, which is 4 plus 3. That's equal to 7. Now, do we need to find the QR? No, you didn't see that, did you? So do we need to find the QR here? Not necessarily. Why? Because PR, the whole thing, or pi r rather, sorry, pi r is 2 times pi q. P was right. PR is equal to PQ times 2, right? We could find QR as well. It will be the same thing, right? QR is equal to 2 times 4 minus 1, which is also 7. So the answer is going to be 7 times 2, which is 14. On the segment PS above, PR is 12. PR is 12. QS is 16. And QR is equal to 1/3 of PS. What's the length of PS? Okay, so the length of PS. Okay, there's a lot of information here. Let's see what we can make from them. So QR, this seems like the most useful one for now. 1/3 of PS. Okay, that's fine. QR is 1/3 of PS. Good. Now, what do we know about PR and QS? We know one is 12, the other one is 16. So when we add PR plus QS, we get more than PS because there's an overlap of QR. So there's this section here is overlap, so we count that twice. Right? So if I'm counting that twice, that means if I subtract PS, or sorry, not PS, QR from this addition, that should give me PS. Fair enough? So PR is 12, QS is 16. Minus QR. QR, now we can do the substitution here, which is 1/3 of PS is equal to PS. 28 is equal to, move the 1/3 of PS to the other side, that's going to be 4/3 PS. And now we can do some cross multiplication. But before we can do the cancellation here, 7 times 3 is 21. So 21 is equal to PS, or PS is equal to 21. A bit of a tricky question, but a good one. In the figure above, AB is equal to 2/3 of BC. What's the length of AC? So AB, what's AB? AB is x plus 3, is equal to 2/3 of BC. What's BC? 3x minus 6. Cool? Now, if we find x from here, that can give us AB, and then we can find BC, and then we can find what AC is by adding AB plus BC. So let's solve it. X plus 3 equal to, open the brackets here. When we multiply this, 3's will go away. 2x minus, when we multiply this, again 3's will go away. This will be just 4. X is on one side, numbers on the other side. So x is equal to 7, which means AB is equal to 7 plus 3, which is 10. And BC is going to be 3 times 7 minus 6, which is 21 minus 6, which is, what is it, 15? So 15 and 10. So AC is equal to AB plus BC. That's equal to 10 plus 15, which is 25. So the answer is going to be D. All right, moving into angles. Now, I want to say a few things before we start doing some problems. Some stuff that we will need to remember in terms of wording. Okay, so we have 4 different types of angle. We've got one acute angle which is less than 90 degrees. So between 0 and 90. Then we've got right angle, which is equal to 90. We've got obtuse angle, which is greater than 90 and less than 180. And last one, we have straight line or straight angle, which is equal to 180 degrees. Okay? What else do we know in terms of wording? We have supplementary angles. Supplementary angles, where should I write a supplementary here? Supplementary angles. Now, what do we know about supplementary angles? We know that they should add up to 180 degrees. Sum equal to 180 degrees. What's the example of that? If you have a line like that, let's say this is angle 1, this is angle 2. So angle 1 and angle 2 are supplementary angles. Now, what is complementary angles? Complementary angles. Now, these angles should add up to 90 degrees. Okay, so think of it this way. This is a 90-degree angle. If I draw a line, this is 1, this is 2. 1 and 2 adds up to what? 90 degrees. In the figure above, what is the value of x? Now, from the image that you saw, these are supplementary angles, not complementary, but supplementary angles, which means they should add up to 180 degrees. So 40 plus x minus 90 should be equal to 180, right? Move the 40 to the other side. X minus 90 is equal to 180 minus 40. X minus 90 is equal to 140. X is going to be 140 plus 90. And x is going to be, what is it? 60 here and 30 there, 230. So x is going to be 230. Moving on. In the figure above, what is the values of y? What is the values of y? I wonder what does it say values, but what's the value of y? Now, what do we have here? We have 3 angles that are given. Now, I don't know if I don't think we talked about it, but these angles are called adjacent angles, which means they're equal to each other. So the black ones and the red ones are not black equal to red. So the black ones are equal to each other, and separately, red ones are equal to each other. So, and what else do we see here? Let me delete that actually. So, which means I can write 3y minus 8, 5x minus 12. That doesn't give me much because there's only one equation but 2 variables. But I can also make a supplementary angle from these two, meaning x plus 3y minus 8. I know it should add up to 180 degrees. Okay, so now I have simultaneous equation situation. I can probably solve that and find my answer. But there's another supplementary angle that we can use, which is this one. So x and 5x minus 12. X plus 5x minus 12 equal to 180 degrees. Now, we have three equations. 1, 2, and 3. And we only have two variables. Like I said, we can use 1 and 2 to do a simultaneous equation. We certainly can. But the third equation makes our life a little easier because it only has one variable. Okay? So which means we can solve it. Equal to 192. And x is going to be equal to 34, if I'm not mistaken. 34. I think I am mistaken. 32. 32, which means we're looking for value of y, which means we can now substitute that into actually either 1 or 2. Doesn't matter. Doesn't matter. I'm going to do it in equation 1. So 3y minus 8 is going to be equal to 5 times 32 minus 12. So 3y minus 8 is going to be equal to 5 times 32 is, I want to say 160. 160 minus 12, that's going to be 148. So 3y equal to 148 plus this 8, which is 156. And y is going to be equal to 156 divided by 3, which is 52. Yes, 52. And the answer is going to be A. In the figure above, ray OB bisects COA, which means it divides it into two equal parts. So these angles are equal to each other. That's why we have these lines. If DOB is equal to 11x plus 6 and COA is equal to 8x minus 12, what is the measure of DOC? Okay, so COA is equal to 8x minus 12, which means we can find what angle, let's say, COB is equal to, or angle BOA equal to, because they're equal to each other, which is going to be half of 1/2 of 8x. Let me write it down here. It's going to be equal to 1/2 of 8x minus 12. And I can open the brackets. That's going to be 4x minus 6. So this part is 4x minus 6. This part is 4x minus 6. And I know DOB is 11x plus 6. So I already know this part, which is 11x plus 6. So what I will do, I'm going to get rid of this one. Now I know I have two angles here, DOB and BOA. And they're supplementary angles, so they should be equal to each other. So DOB plus BOA should be equal to 180 degrees. Now I can substitute 11x plus 6 plus 4x minus 6 should be equal to 180 degrees. 15x, are these both 6? So they go away, is equal to 180 degrees. X is going to be what? 180 divided by 15, 1, 2. I think it's 12. So x is 12. But what are we looking for? We're looking for DOC. DOC. Now, to find DOC, we can do two things. So we can find what this is, which is just double the 4x minus 6. We can find what COA is, and we can subtract. So angle COA is equal to 8x minus 12. That's given. So 8 times 12 minus 12, which is going to be, I want to say, 84. 84. And so the angle DOC is going to be 180, because they're supplementary angles, minus 84. And I don't know what that is, 96. 96. There you go. All right, last question on this one. Let's make it a bit smaller. All right, last question here. In the figure above, ABE is equal to 120 degrees and CBD is equal to 135. What's the measure of TBE? What's the measure of TBE? Now, when we add, again, these are supplementary angle questions. So angle ABE plus angle D, and this is angle DBC, supposed to be, they have an overlap. They have an overlap, which is the DBE. So we double count it. So DBE counted twice. So if we minus one of them, DBE, in the figure above, AB is equal to 120 degrees and CBD is equal to 135. What's the measure of DBE? All right, so ABE and CBD they have an overlap, which is this part. DBE is overlap. So they both have that piece. Again, this is similar to the previous questions, which means there has been a double counting. So if I take ABE, angle ABE, plus angle DBC, and minus angle DBA, should get me to what? 180 degrees. Again, because these two, the first two, has a double count of DBE. That's why I'm subtracting one of them. Okay? Now, what's ABE? 120 degrees. What is DBC or CBD? Doesn't matter. 135 minus angle DBE equal to 180 degrees. So angle DBE is going to be equal to 120 plus 135, that's 255 minus 80, that's going to be 75 degrees. Okay? Well, last thing we're going to look at is parallel and perpendicular lines. So this is parallel line, this is perpendicular line. Now, what do we need to know here? This is very simple stuff. It always comes up. Once you learn it, it's kind of hard to mess it up. So, what do we know about these angles? We know that angle 1, I'll just say 1, I don't want to put angle sign, 1 equal to 3, that's a very curvy C. That's equal to 5, and that's equal to 7. Now, 1 and 3, they're adjacent angles. 3 and 5, they're equal based on the parallel lines rule. And 5 and 7 also adjacent angles. So these 4 angles are equal to each other. Same goes for the even ones. 2, 4, 6, and 8. They're equal to each other as well. But they also, with these lines together, they create supplementary angles. So 1 and they all add up to individually, not together. Individually, they add up to 180. What do I mean? So if you take 1 and 2, they should add up to 180. If you take 4 and 3, they should add up to 180. 180, 180. Doesn't matter, okay? Even you can say the same thing for 5 and 8, 6 and 7. Okay? So they add up to any combination of this, they add up to 180 degrees. Okay, now what's the deal here with the perpendicular lines? Same stuff. It creates 90-degree angles all around, and they're all equal to each other. Okay, but the parallel ones is a bit the tricky one because, you know, usually questions come from that. So let's solve some problems. In the figure above, R is parallel to T. This is a parallel sign. What is the value of x plus y? X plus y. Now this image is basically the previous image but rotated. Okay, in fact I can redraw that for you. So this is parallel lines. Imagine there's a line like that. So this part, okay, well, how should I put this one? So the big one, this is a bigger angle, so I'll take this one here, 5x This is 5x plus 4. This one is going to be 5y minus 9. And the opposite of 5y minus 9, this is 3x. Okay, so these two are same images. I know they look a bit different, but they are same. So what do we know? We're looking for x plus y. Okay, that's interesting. We're not looking for x and y. We're just looking x plus y. So I'm suspicious that we might not even need to find what x and y is. So what do we know about these two? As I said just now, a minute ago, these are supplementary angles, which means they should add up to 180 degrees. So let's see. 5y minus 9 plus 5x plus 4 should be 180 degrees. So 5y plus 5x, and let's move the numbers to the other side. 180 minus 4 plus 9. This part is just plus 5, so 185. So 5y plus 5x is equal to 185. Now, as you can see, we're looking for x plus y. So I can factor out 5 from here. Y plus x equal to 185. And divide both sides by 5. That's going to be y plus x equal to, I want to say 3 and 7. 37. So the answer is going to be A. In the figure above, m perpendicular to n, again, similar question. If A is equal to 50, A is equal to 50. Now, before even continue any further, here's what I like to do. If this is 50, I know this is 50, right? I know, what else do I know? I know this is 50. If this is 50, then I know this part is 130 degrees. This is also 130 degrees. This part should be 130, but we'll see if we need that. So let's keep it right here. And B is 120. So this is 120 again, which means this part is going to be 60. This part is going to be 60. This is going to be 60, right? And this part is 120. So what are we looking for? I haven't even read the question, but what's the value of C? We're looking for C. Okay. Now, this big piece here is all three supplementary angles, meaning 30. Oh, is that 30 or 50? 50. 50 plus C plus 60 should be equal to 180 degrees. So C plus 110 equal to 180, and C is going to be 70 degrees. So 180 minus 110. C. In the figure above, lines L, M, and N are parallel, so we have three lines here. What is the value of x plus y? Okay, now this whole thing seems to be 70. Okay, interesting. Interesting. Let's see what we can find out. So if this is y, that means this is also y, right? If this is x, that means this is also x. Ah, there you go. So, and we know that full circle is equal to how much? 360. Yes? So, again, this could be sort of supplementary. So x plus y plus 70 should be equal to 360. Fair enough? By the way, how did I know this is y, this is x? Based on the parallel line rules. Okay, so x plus y is equal to 360 minus 70, and that's going to be 290. So we're looking for x plus y. The answer is D. All right, last one. In the figure above, L parallel M, what's the value of x? So this is 55 again. Before worrying about x, I know this is 55. Yes? I know this is 125. Not sure if I'll need it. 125. But we're looking for x, so there's a triangle here. Let's give it a name. A, B, and C. And we know the internal angle of triangle is supposed to be adding up to 180 degrees. So 55 plus this one, which is 90 degree, as it's shown in the image, it's a right angle triangle, plus x should be equal to 180 degrees. So 135 plus x is supposed to be equal to 180, and x is going to be equal to 35. So there you go. Okay, that concludes what I want to talk about today: lines, segments, and parallel perpendicular lines. I guess the whole thing goes line and angles. Okay, tomorrow I'll have, or maybe later today, I'm not sure, there'll be another geometry session which will be about triangles, and then potentially there'll be another one which is going to be covering other figures than triangles. Okay, so make sure you do your reviews. The exams are getting very close. We're a bit more than a week away from the exams. Make sure you do a lot of examples, and let me know in the comments if you have any questions and what would you like to see next besides these daily review videos. All right, thank you for tuning in. Hopefully you learned something, and take care.